What if I told you that one of the tiniest, most underestimated creatures on Earth could lead you straight to diamonds? Yes, diamonds. Not through magic, not through fiction, but through a real natural phenomenon backed by science, geology, and years of exploration. In this video, we'll uncover the fascinating connection between termites and diamonds, and how these tiny excavators have been unknowingly guiding geologists and miners to some of the most precious stones buried deep in the earth. So buckle up, because by the end of this video, you'll never look at a termite mound the same way again. Let's dig in. Before we meet our six-legged assistants, let's understand the big picture. What exactly are diamonds and how do they form? Diamonds are formed 100 to 150 kilometers beneath Earth's surface, under intense heat and pressure. Over billions of years, carbon atoms crystallize into this perfect, unbreakable lattice. And voila, a diamond is born. But how do these diamonds get close enough for us to find? The answer lies in Kimberlite pipes, ancient volcanic conduits that transported diamonds from the Earth's mantle to its surface. Over time, erosion wears these Kimberlite rocks down, sometimes scattering diamond-rich material into rivers, stream beds, and even soil layers. And this is where our unexpected heroes, the termites, come in. Termites are often dismissed as pests, but in nature's underground network, they're engineers. These tiny insects dig through soil, bring up minerals, and construct mounds that can reach several meters tall. But what's fascinating is what they unknowingly bring to the surface. Termite colonies can access deep subsurface soils, often much deeper than human prospectors might think to sample. As they tunnel and scavenge, they can transport tiny fragments of kimberlite, garnets, chromites, and even indicator minerals that are geologically linked to diamond deposits. In countries like Botswana, South Africa, and Australia, researchers began to notice a strange pattern. Termite mounds were consistently rich in mineral traces associated with diamonds. This discovery flipped the script. Instead of just drilling endless holes in the ground, scientists started analyzing termite mounds to zero in on potential diamond sources. It's like nature gave us a free sampling service, and we just had to start paying attention. Let's look at the real-world evidence. In Botswana, one of Africa's richest diamond regions, geologists began analyzing termite mounds for traces of ilmenite, magnetite, and pyrope garnet, all of which are known indicator minerals of diamond-rich kimberlite pipes. And the results? Stunning. In many cases, termite mounds tested positive for these indicators without a single drill having hit the ground. In Australia, researchers from CSIRO developed special testing kits to analyze termite mound material. One test revealed kimberlite fragments that were 100 meters below the surface, without disturbing the land. That's the power of bioprospecting, using biological activity to map geological treasures. Termites have helped researchers map hidden diamond pipes, reduce costs for exploration, and even limit environmental destruction by reducing the need for aggressive drilling. So yes, termites are now part of the modern gem prospector's toolkit. But how exactly do you analyze termite mounds? What are you looking for? The top signs include magnetite, a magnetic mineral that often accompanies kimberlite, chromite and ilmenite, black minerals linked with high-pressure geology, pyrope garnet, a reddish gemstone that's a strong indicator for diamond presence, kimberlite rock fragments, light-colored, crumbly pieces that may hold diamonds. Geologists use portable X-ray fluorescence, PXRF devices, to scan samples on site, sometimes right next to the mound. If promising indicators show up, sampling and microprobe analysis can be done to confirm the Kimberlite origin. It's precise, low-cost, and environmentally friendly. Termites are essentially natural geological scouts, filtering what lies deep beneath. This strategy is now called biogeochemical exploration, and it's transforming how we approach diamond discovery. Now here's the question most enthusiasts are asking. Can you, as a gemstone explorer or small-scale prospector, use termite mounds to your advantage? Yes, but with a cautious, educated approach. Here's what you can do. 1. Know your geology. Termites are only helpful if you're already in a diamond-bearing region. Focus on areas near known kimberlite fields, like Ethiopia's Rift Valley, Angola, or northern Canada. 2. Look for unusually large termite mounds. Older mounds often bring up material from deeper layers. 3. Use a metal detector or handheld mineral analyzer. These tools can give early indications of iron-rich or volcanic rock content. 4. Collect samples carefully. Don't destroy mounds. Collect soil from the base and around ventilation shafts. 5. Watch for sparkle. You might find tiny garnets, chromite crystals, or even microdiamonds in your sieve. 6. Stay ethical and respectful. Many termite species are essential to the environment. Take only small samples and leave the habitat intact. Termite-assisted prospecting could be a low-cost breakthrough for rural gem hunters and responsible small-scale miners. We're here to educate, promote responsible exploration, and connect you to the tools and science that make the difference. If you're looking to learn, explore, or even invest, subscribe to EGS Pro, where we turn earth science into gem power. So next time you walk past a termite mound, don't just see dirt. See a map, a gateway, a whisper from the Earth's hidden vault. Because in the world of gemology, it's not always about what shines on the surface. It's about knowing what lies beneath. Diamonds may be forever, but finding them, that takes a little help from science, instinct, and sometimes even termites. This is EGS Pro, and we're here to bring you the untold, the uncut, and the unbelievably true stories of the gemstone world. Subscribe for more rare discoveries, gemstone education, and mind-blowing mineral content. Hit the bell so you never miss the next sparkle of truth. Can rats accidentally lead to diamond deposits? Have you ever wondered if one of nature's most unsuspecting creatures could be quietly leading us to some of Earth's most precious treasures? They dart between shadows, they burrow where no one looks, and they collect what we throw away. But what if rats could uncover what millions of dollars in high-tech exploration sometimes fail to find? What if the trail to diamonds wasn't marked by machines or satellites, but by the restless paws of rodents? This isn't fiction. This is the story of how rats might just be the secret prospectors no one's paying attention to. Let's begin at the unlikely crossroads of biology, geology, and behavior. It's no secret that rodents are collectors. They hoard food, nest materials, even human objects. But recent field studies have suggested something startling. In certain mineral-rich zones, rats have been observed dragging tiny, reflective stones into their burrows. These aren't ordinary rocks. Some contain microdiamonds, naturally occurring crystals that, in the right context, indicate proximity to a diamond-bearing kimberlite pipe. It all begins with the rodent's survival instincts. They're drawn to objects that are cool to the touch, have a certain weight, and reflect light subtly, traits that coincidentally describe raw diamonds and indicator minerals like garnet, olivine, and chromite. They don't know what they're collecting, but we do, and that opens a door. Diamonds form over 100 miles beneath Earth's surface, where heat and pressure compress carbon into perfect crystal lattices. But they don't stay buried forever. Volcanic eruptions, millions of years ago, blasted them up through narrow pipes of solidified magma known as kimberlite. Over time, erosion scatters these diamonds across riverbeds, hillsides, and even deserts. But here's the catch. Most of these diamonds are tiny, some invisible to the naked eye, and they often end up lodged in surface rocks or deep in animal-accessible soil. Which brings us back to our rodent friends. In 2017, geologists in South Africa documented rats dragging unusually heavy pebbles into their dens. Upon testing, several contained pyrope garnet and chromite, two minerals geologists prize as diamond indicators. In Western Australia's mineral belts, another expedition found that rat burrows in dry scrubland had accumulated sediment from deeper layers rarely exposed above ground. Some of this dirt contained ultramafic minerals commonly associated with kimberlite systems. Now, were these diamonds themselves? Not always, but they were breadcrumbs. And in geology, breadcrumbs are gold, figuratively speaking. The rodents, unaware of their contribution, were digging naturally what humans usually drill artificially. A rat can burrow over a meter deep, pulling dirt, stones, and minerals into its den. In doing so, they bring unexposed layers of earth to the surface. Layers geologists might otherwise need to excavate with heavy equipment. In essence, they're tiny, furry geotechnical samplers. And they're free. What if we told you there are researchers now exploring the potential of using animal activity, particularly burrowing behavior, as a mapping tool for mineralogy? It's no longer a joke. In places too remote for equipment, too ecologically sensitive for heavy surveys, or too politically volatile for industry operations, the humble rat may be the best tool we've got. Diamonds rarely travel alone. They tend to co-occur with specific host rocks, like kimberlite and lamproite. And those rocks contain a cocktail of minerals that rats can accidentally pull up. For example, ilmenite, slightly magnetic and heavy; chromite, dark and reflective under certain light; pyrope garnet, vibrant reddish-purple; olivine, glassy and greenish. Each of these may catch a rat's attention, just like they catch a geologist's. And if rats are digging them up from places humans haven't explored, then they're unknowingly revealing veins, pipes, or scatters no one else has noticed. It's a literal gold mine, without the gold. Or, sometimes, with it too. Now picture this. A team of scientists in Angola equips a small rodent colony with micro-GPS tags. They track movement, map burrows, analyze sediment samples. In their dens, mineral traces pointing to a possible kimberlite intrusion. This isn't hypothetical. The field of bioprospecting, using biological clues to locate resources, is on the rise. And animals, from termites to rats, are becoming part of the strategy. They sample the ground naturally. Their instincts become geoclues. And in terrain where human activity is dangerous or impossible, the smallest digger might be the smartest ally. So now, here's the question. If a rat can show us the way, if its instinct can point to one of Earth's rarest treasures, why haven't we looked more closely? Deep beneath this layer of soil lies a mystery, not one planted by man, but uncovered by creatures no bigger than your forearm. In remote corners of the Earth, their burrows hold answers. And in one forgotten Siberian outpost, the tiniest trail led to a discovery that changed everything. In the tundra regions of Yakutia, where winter covers the land in silence, a small geological team was investigating permafrost shifts, not diamonds. But during that winter, they stumbled upon a peculiar pattern. Rodent burrows near a set of granite ridges had pebbles arranged near their entrances, likely dragged from deeper underground to line their dens. The pebbles weren't ordinary. They were eclogite fragments, rocks only found in extremely high-pressure environments. One of the geologists recognized the garnet-rich signatures in order to follow up. Drilling revealed a kimberlite intrusion missed by years of aerial surveys. And it was rich, not only in diamonds, but in a new understanding, Rodent activity had surfaced a buried volcanic pipe, completely by accident, or so we thought. Why are rats drawn to these minerals in the first place? The answer lies in their sensory world. Rodents have evolved to detect fine temperature shifts, tactile surfaces, and mineral textures as part of their foraging behavior. To them, a cool, heavy stone may signal a stable burrow anchor. To us, that same stone may scream, "Diamond indicator." But what if this isn't random? Some scientists now propose that certain rodent species develop local nesting preferences over generations. In areas where kimberlite rocks lie closer to the surface, rats may instinctively select specific mineral textures for structural or nesting reasons. In that sense, the behavior may be part instinct, part evolution, and part accidental brilliance. High-resolution satellite imagery has revolutionized gold and diamond exploration, but what tech can't see, burrowers might reveal. Imagine coupling AI-powered rat tracking with geochemical sampling, not to study the animals, but to study their choices. Each den becomes a micro-sample point, each collected pebble a possible data node, each cluster of activity a heat map. You wouldn't just watch the terrain, you'd watch who's interacting with it. Prospectors of the future might monitor animals instead of the soil. From diamonds to gold, the wider application. While our focus is diamonds, this concept doesn't stop there. Rats and other burrowing mammals interact with a wide range of minerals. In gold-rich soils, they've unearthed quartz vein samples and iron-stained clays. In copper belts, rodent burrows sometimes contain traces of malachite. In opal zones, disturbed dirt can glow under UV due to hydrated silica residues. This means the strategy could scale, from diamonds to gold to rare earth minerals in contested regions. Wherever the earth holds secrets just below reach, animals are, sometimes literally, bringing them to the surface. And they do it without GPS, without machines, without even knowing it. Of course, not everyone's convinced. Critics argue that relying on animal behavior is too inconsistent, that burrows are chaotic, that rats don't intend to help us, and randomness can't replace rigor. Fair points. But here's the truth. Even modern geologists use randomized surface sampling to find indicators. Rodents may be chaotic, but so is nature. And chaos, when repeated enough, can form patterns. All we need is to notice them. With rising tensions over mining land, ecological preservation is now key. Using animals as natural proxies for mineral indicators offers a low-impact alternative in regions too delicate or sacred for drills. This isn't just efficient, it's respectful. It's strategic. A single rat colony could point to a cluster of resources previously undetectable. And in a world where the next diamond field could lie beneath protected land or dense wilderness, watching nature's smallest miners might be the smartest move. They don't know what they carry, but they might be carrying everything we've been looking for. So next time you cross a field or walk near rocky outcrops, remember this. That tiny rustle in the bushes, that hole in the dirt, that trail of scattered pebbles might just be the path to the next great diamond discovery. Unmarked, unclaimed, unbelievably real, and led by creatures that never meant to lead. If you're still looking at the ground hoping for signs, it might be time to look closer. Not just at the soil, but at who's moving it. Because in the silent, scurrying paths of rodents, the earth may be whispering the location of its deepest secrets, and it's our job to listen.